So, you finally built your SaaS. It runs perfectly and customers are already signing up. Life is good. Until one day someone asks, why can I see data of other people? And just like that, one simple bug turns into a massive problem. And now the question arises, how can you handle multiple customers in one application without ever mixing their data? Well, that's exactly where multi-tenancy comes into play. We will start by looking at what multi-tenancy actually is, we will compare it to single-tenancy, and we will even dive into database strategies. This means one database per tenant versus one shared database. And finally, we will compare all of the strategies and look at pros and cons. Oh, and you thought we were finished? No, we will even implement multi-tenancy in a Next.js application together. I will show you how to use a shared database and leverage tenant IDs to keep all of your data perfectly separated. Plus, we will even explore a neat trick with the Decorator Pattern to make sure that your queries always respect tenant boundaries. Sounds exciting? Well, without any further ado, let's roll the video. Let's go! Let's start by first of all looking at single tenancy versus multi-tenancy. And here you should see something quite interesting. Single tenant, multi-tenant. What is a tenant? Good question. A tenant is a single customer or organization. This means in theory, a tenant could be you, I could be a tenant, and my friend John could also be a tenant. But also, as mentioned here, an organization can be a tenant. So let's say that, for example, we have Amazon. Amazon is a big company. It's an organization. And Amazon has many members, employees. Nevertheless, you still look at Amazon as a tenant, even though that they have multiple members, multiple employees. This means whenever you think about multi-tenancy, single-tenancy, you don't think about singular users. They are not interesting. What you want to look at are tenants. But now let's look at single-tenancy. And here you should see something interesting. We have users or maybe tenants, who knows, then some sort of application, database. What do we see right here? What does this diagram show us? Good question. So what's the fundamental idea of single tenancy? Well, in a single tenant application, each customer, or in other words, each tenant, has a completely isolated instance of your application, including a isolated database. So let's imagine the following. This is you. You are tenant number 1. This is Google tenant number 2, and this is Amazon tenant number 3. In theory, these two tenants also have employees, members, but that's not very important. In general, we have 3 tenants. And now each tenant has their own application, you could say their own server, and also their own database. And this is a key characteristic of single tenant architecture, because there is no sharing of resources. This means this tenant, you don't have access to this server, this application. You also don't have access to this database. You only have access to your own application and to your own database. And with application, I literally mean your application. So in this case, Marshall Code, this is my application. And what is an application at the baseline? Well, it's kinda a server. This is your server, this is your database, and you have with that a completely isolated instance of the application. And this is very interesting. And now you might ask me, okay, Jan, so I see what single tenancy is. I have my own application, my own database, or in other words, each tenant has their own application, their own database. There is no sharing. But what's the difference to, for example, multi-tenancy? Good question. So here on the right, I created a diagram for multi-tenancy. We again have 3 tenants. You, Google, Amazon. And now here is the interesting thing. We only have one application and one database. Wait, does that mean that we share resources? Yes, this is the important distinction with multi-tenancy. Now, you don't have your own instance of the application, your own instance of a database. Instead, you share resources by sharing the application, the server, but also the database. So you only have one database. And now you might say, okay, Jan, so in a single tenant architecture, each tenant has their own instance of the app and database. And in a multi-tenant application or architecture, we share resources. But how do we make sure in a multi-tenant architecture that tenants don't see data of other tenants? Because as mentioned here, there's no way, like physically, there's no way for a tenant to access data from a different tenant. They only see their own data because they only have access to their own database. But in a multi-tenant architecture, this tenant shares the same database. This means in theory, this tenant could also see data of other tenants, right? Yes, in theory, this is correct. And that's why you want to pretty much segregate your data using a tenant ID. So whenever you fetch data, so let's say you would create a query to get block articles, so constant data equals to get block, and the important thing is that you would now use some sort of where statement where you would say, hey, the tenant ID has to be equal to the tenant ID which I pass. And with that you make sure that you only get data from the correct tenant and that a tenant can't access data from other tenants. This is super important. But for now, let's not really think about security. In general, you now know what the difference is between single tenancy and multi-tenancy. But as mentioned, there is another variation, because in theory you can also create one database per tenant, and this is still multi-tenancy. Let's look at this diagram in detail. So option 2 is what I showed you 1 second ago. We share one application, one server, and one database with all of the tenants. So all tenants share resources. But this option 1, variant 1, still has 3 tenants, you, Google, Amazon. We still share the application instance, the server, but each tenant gets their own database. You get this database. Google or Amazon, I think this is Google, gets this database, and Amazon gets this database. So even though our tenants share the same application instance, their data is now segregated by having their own database. So now you know the difference between single tenancy, multi-tenancy, and now you also know that there are 2 options to implement multi-tenancy. But now you might ask me, okay, Jan, that all makes sense, but what should I use? What's the best solution for my SaaS? How can I make the most money possible? Now you probably expect some sort of absolute answer. Hey, this is better or this is better. Now here's the thing. There is no absolute answer. There is nothing that is better or worse. There are certain use cases where certain architectures work better. So I created this simple diagram which shows the pros and cons of single tenancy, multi-tenancy with one shared database, and multi-tenancy with a separate database per tenant. So let's get started by looking at isolation. And no, I'm not talking about 2020 where we had to isolate, but rather about data isolation. And who would have thought single tenant architecture wins in this case? And why is that? Well, that's because every tenant has their own infrastructure, their own application, their own server, but also their own database. There is no way physically to access data from other tenants. And that's why single tenancy wins in terms of isolation. Multi-tenancy with a shared database loses. And that's because, again, we only have one database. Yes, there are ways to make sure that data leakage does not happen or that other tenants can't access your data. Nevertheless, still, it's one database and it's way harder to make sure that something like that does not happen. But once we implement multi-tenancy, I will show you a solution to make sure that your data is always bound to a tenant ID so that there's no leakage or anything like that. And multi-tenancy with separate databases is relatively safe. I mean, it's relatively isolated because you still have separate databases. Only your app layer, your server is shared. And in most cases in the server layer, you don't really have very sensitive data. In terms of cost, single tenancy is the most expensive because at the end of the day, you have to implement a new infrastructure infrastructure layer for every tenant. Multi-tenant architecture with a shared database is the cheapest one. That's because you only have one database and one server. You only pay for two things instead of paying for hundreds of databases and hundreds of servers. And multi-tenancy with separate databases is somewhere in between. It's not super expensive, it's not super cheap, because your server scales quite nicely. You don't have to create or buy multiple servers, but you have to always get new databases whenever a new tenant signs up. So it is expensive, but it's cheaper than single tenancy, but it's more expensive than multi-tenancy with a shared database. In terms of scalability, multi-tenancy with a shared database wins because it's very easy to scale and it's also relatively cheap to scale. Single tenancy is quite expensive because when you want to scale, you have to buy more machines, more servers, more databases, and with multi-tenancy and separate databases, it's also relatively easy to scale, but you have to always adapt or buy new databases to scale. Let's also look at customization, and in terms of customization, single tenancy is literally the best thing ever because every customer, every tenant has their own infrastructure, which also means it's super easy to customize literally everything. If you want to customize the login page, easy, done. If you want to customize the server, easy, done. If you want to create or use a different database instead of MySQL, you want to use Raven, a NoSQL database, then easy peasy, because again, every tenant has their own infrastructure. In terms of multi-tenancy with a shared database, it's not that easy because we only have one database and only one app, one server. So it's not very easy to customize. And multi-tenancy with separate databases is a bit more customizable because here's the thing, the server is still the same, it's still shared, but it's easy to update the database. So for example, one tenant could have one schema, one database schema, and a different tenant could have a completely different schema because this tenant, for example, has certain features that they need and they pay more. So this is also super interesting. And another thing we have to look at is maintenance. This is super important once you scale because single tenancy, yes, it's cool, but it's very hard to maintain. Whenever your application grows, you have to also maintain multiple servers, multiple databases. Good luck doing that. Multi-tenancy with a shared database is easy to maintain because you only have one application, one database, and multi-tenancy with separate databases is a bit harder to maintain because you now have multiple databases that you have to check, and whenever you want to make a schema update or you want to update the schema in general, then you have to update the schema for every database, which can be quite annoying if you have like 100 plus databases. And the last thing I want to look at is compliance suitability, and this is super important for like super niche products. What do I mean by that? Well, let's say you want to sell something or your software to the healthcare sector, to some sort of, you could say, hospital. In most cases, you then need, or not in most cases, in every case, you need to be HIPAA compliant. This is very important. And here's the thing, you only get HIPAA compliance in most cases if you use single tenancy, because you have to install this whole software pretty much on the infrastructure of your customer. So if you sell software to a hospital, then you will have to install your software on their machine, on their server, on their database, and so on. So whenever you need to get compliance, which is not easy to get, then single tenancy makes a lot of sense. Of course, multi-tenancy with a shared database loses in this case. It's still achievable, but it's not as easy anymore because there are way more risks with one shared database. And multi-tenancy with separate databases is relatively easy, or in other words, it's very easy to be suitable for compliance because you have separate databases and all of the sensitive data lives in the database and not in the application instance itself. Look, so now we are finished with the theoretical part of this video. We covered single tenancy, multi-tenancy, one database per tenant, one shared database, the pros and cons of each architecture. But now let's look at the practical side of things. In other words, it's time to implement multi-tenancy into a real application. And that's why I spun up this nice application. So on the top, or first of all, what even is this application? What does it do? Well, this is a multi-tenant block application. We have multiple organizations, and for each organization, a user, a member, can create an article. So in this case, on the top, I first first of all have a navbar as you see here. And on the left, I have a switcher, an organization switcher. And I'm a member of 3 organizations, Google, Amazon, Facebook. And on the right, you see the tenant ID, in this case Google, because I'm signed into the Google organization. If I switch to the Amazon organization, the tenant ID will update and it's now Amazon. This is super important because this tenant ID will be used for in our database to link the content to the specific tenant. So here we want to render all of our blog articles. Currently, I don't have any blog articles because who would have thought I haven't set up any database yet, and I can create an article. If I click on create blog article, I can add a title, content, image, and then once created, this blog article will be linked to the organization itself. And here's the thing, a lot of people often get confused by tenant, organization, customer, workspace, tenant ID, organization ID, workspace ID. What should you use? Well, here's the thing. Essentially, everything is the same. What I mean by that is literally pick one and use it everywhere. So as an example, tenant ID, if you choose tenant ID, use it everywhere. If you choose organization ID, use it everywhere. Don't mix and match. This is not good. Please stay consistent. But now, as mentioned, currently I did not set up any database yet, and it's time to change that. And that's why I want to introduce you guys to RavenDB. RavenDB is the database which we will use in this video. And RavenDB is a fantastic choice for multi-tenant applications. But now you might ask me, hey Jan, what even is RavenDB? So RavenDB in a nutshell is a modern document database, NoSQL by design, built to give developers flexibility and performance without sacrificing strong guarantees. RavenDB stores your data as JSON documents, supports distributed clusters, automatic indexing, which is super powerful, full text search, and ACID transactions. All things that make it a compelling option when you are building apps that need scale and support for many tenants. One of the things that I personally like about RavenDB is how developer-friendly it is. As they say, the boring database, and that's because they want you to spend less time wrestling with the database and more time writing your application logic. And there is a fresh twist. With the recent version 7.0 and above, RavenDB is extending into the AI space. They offer vector search, generative AI workflows, and even database native AI agent creation. And this means for you, if you are building a multi-tenant application, you don't only get the ability to segment data by tenant and manage isolation, you also get all of the underlying tools for efficiency, scale, and even AI-enabled features right in the same database platform. Oh, and by the way, did I already mention that RavenDB is completely open source and with that self-hostable? Yes, you heard right. As you see here, this is the repo. Don't forget to star it. And since you now know what RavenDB is and why it's so cool, I guess it's time to implement RavenDB, or in other words, to connect it to our application. So there are 2 ways to get started. You can either start with a free cloud instance. This is completely free. You don't have to add any credit card and it will automatically set up everything for you. But as mentioned, RavenDB is completely open source, which means you can also install it locally on your machine by either installing it right here or using Docker as an example. But in this case, I will click on download on premise. It will redirect me to this website and I want to install the latest stable version, which is 7.1.3. So I use Mac OS with a M series chip and I will click on download. Now RavenDB downloaded for me and it downloaded a zip file. So I will unpack the zip file with my archive utility. So as you see here, it unpacked everything successfully. I have a new folder, RavenDB. I will open it and inside of here you will find a file called run.sh. I will double click on it and this will now open the Raven dashboard. So in this case, I will scroll to the bottom and click on accept. The next step is to select whether we want to set up a new cluster from scratch or continue the setup using an existing setup package. In this case, we will create create a new cluster and I will click on next. The next step is to choose your security level. So we will select unsecure because currently we are in a development environment, but once you deploy your application or once you move into production, I would highly encourage you to click on generate Let's Encrypt certificate. So as a next step, I will click on next. Inside of here, you want to set your node addresses. So I will just leave the default as is. And the next step is to click on finish. So configuration completed. And the last step is to restart the server. As you see here, I got an error, but after a few seconds, it now loaded my dashboard. So this is already the dashboard and we see, hey, the CPU usage, the traffic, average request time, and so on. But I want to create a new database. So on the left, you will see that we have a sidebar and I will click on databases and I will create a new database. So let's click on this magic button. For the name, this will be Multi-Tenant, and let's click on next. So inside of here, we can enable sharding. And what even is sharding? Well, sharding is a database partitioning technique that breaks up large databases into smaller, more manageable pieces called shards. And each shard contains a subset of the data and can be stored on a separate server, allowing for horizontal scalability and improved performance. So you know what? I will just select sharding, and for the number of shards, let's say 3. But in theory, this is not needed for development. This is just a super cool feature offered by Raven. So let's click on next, and the last step is to click on finish. So this will now spin up our database, and since we now have a Raven database, we can use it to store our data. So let's do that. So to get started, we have to kind of connect our application to RavenDB. So let's head over back to the RavenDB documentation. Just click on the link in my YouTube description, the first one, and let's click on for developers and then RavenDB documentation. Now right here, we have two starting points, either for developers like me and you, but also for DevOps engineers. In this case, I'm a developer, so I will continue with the developer guide. And the first step is to create a document store. So what even is a document store and why do we need it? Well, here's the thing. In order to start, you need to create an instance of the document store, the main entry point for your application, which is responsible for establishing and managing connections between the RavenDB server or cluster and your application. So right here, they have a few code examples for Node.js, Java, and C#. But since we have a Next.js application, we will continue with the Node.js example. But if you secretly use Java, well then you are in luck. But let's for now continue right here. So what do they do in this code example? Well, the first step is to import document store from RavenDB. The next step is to set up the document store. So new document store, and here you should see something interesting. They pass two arguments. First of all, some sort of URL, which is encapsulated in an array, and also some sort of name, probably a database name, right? Yes, correct. So the first argument is the URL to the server. Or, here's the important thing, it could also be a list of URLs to all cluster servers, or in other words, nodes. That's why we have an array right here. And the second argument is the database name. This means the default database that document store will interact with. In this example, they use Northwind, but as you all know, we have a different database name. The second step, which is optional, is to customize the document store. So here they say constant conventions is equal to store.conventions. But here's the thing, again, this is optional. You don't have to customize the document store, and we also won't customize our document store. Nevertheless, it's very cool to have the power to do that. And here's the most important step, and that's to call the initialize method, or in other words, to initialize initialize the store. So each document store needs to be initialized before use. This process establishes the connection with the server and downloads various configurations. As an example, cluster topology or client configuration. Now, this is super important. Please don't forget to initialize your store, because if you don't initialize it, well, then good luck connecting to your server and getting data, storing data, etc. And finally, in this example, they also dispose the store. This means, as they say here, dispose the resources claimed by the document store. But what will we do in a second? Well, essentially, we will have to import the document store, set up the document store by passing the URL to the server and also passing the database name. And finally, we will also initialize the store to connect to the server, or in other words, to the database. So let's go back to our editor, and if you now open your Explorer, you should find a new file called RavenDB. And this is our configuration file, or in other words, in this file, we will set up our document store. Now, I already created an initial version, which is pretty much copy-pasted from the documentation, but we will now configure it, and don't worry, we will go through every line step by step. So the first step is to import server only. And this is important because with this document store, we create a connection to our database server. And this should never be done on the client side. Please, again, repeat with me, never initialize a database connection on the client side. So import server only is a good and very important helper for us, but also for all other developers working on this project. The second step is to import document store from RavenDB. So let's go back to the documentation. And if you scroll to the top, then you should find this section called client. So once the server is up and running, you can start building your application using one of RavenDB's official client libraries. These libraries manage the connection to the server, handle document storage and retrieval, and give you full access to RavenDB features in your programming language. Now, the nice thing is that a lot of languages are supported, but the most important language, Node.js, is of course also supported. So what you want to do is click on this npm link. This will redirect you to the npm website. If you want to, you can open the repository. This is the official repository for the official client. But what you essentially want to do is install the library, the client. So it's called RavenDB. And in your terminal, you want to say pnpm I RavenDB, or if you use npm, then npm I RavenDB. But that's already it. And now before we continue, we need two things. First of all, the URL, and secondly, the database name. So let's go back, and for the database name, let's go to our dashboard, let's go to the sidebar, and I will click on databases. Inside of here, you will find one database, the one which we created, and this is already the name, Multi-Tenant. I will copy the name and paste it inside of here. The next step is to add the URL. And the thing is, if you go back to the terminal, then you will find the URL right here, server available on this IP with the port 8080. So inside of here, I will instead say HTTP localhost with the port 8080. Please make sure that the port is the same one. Don't say 3000 or 3050. It should be 8080. And this is now finished. Let's continue. And the next step is to configure our document store. What I mean by that is we need to add two arguments. The URLs array. In this case, we only have one URL and a database name. So let's pass the two arguments, and with that, this is finished. As mentioned, at the end, we need to initialize the store, and this again creates the connection to the RavenDB server. But now, if you look at the code, you should see something interesting. Global this. Why do we use global this? Good question. Let's head over back to the documentation, and here you will find an interesting section, singleton. So the document store is capable of working with multiple databases. For proper operation, we recommend having only one document store instance per application. And that's why I implemented this global dis. So we use global dis to cache the document store instance in development. And this is super important. It only caches it in development. In production, everything works as expected. And this prevents Next.js hot reloading or hot module reloading from creating multiple instances. So if you have already used Next.js for quite some time, then this shouldn't be something new to you, because for example, if you have used Prisma in the past, you had to implement the same code, because in development everything reloads, and with that you create new instances, and this is not good. So that's why we cache the instance in development. So since we now implemented our document store, we can continue by creating our mutation. So let me quickly restart the dev server to see what we currently have. So this is our index page. This is fine. We don't want to really look at it. Instead, I want to create a new article. And inside of here, I have a card with 3 inputs for the title, content, and image URL. So let's go back. I will open my Explorer, and inside of here, you will find a new folder, create, and a page.tsx. This is the form I set up via hook form. I added all of my inputs, and at the end, I have a submit button. Now this form calls an onSubmit function. So if I scroll to the top, you will find this function onSubmit, and onSubmit calls a server action. So in the folder create, you will find an actions file, and this is the server action. And it's very important that you create the mutation from the server side. Please don't start mutating your data in the onSubmit function. The onSubmit function, or in general this page.tsx, is a client component, so that won't work. Let's head over back to the actions.ts file, and now inside of here we can actually get started with Raven, or in other words, we can now add data or create data in our database. So here's the thing, if you go back to the documentation, you will find another section called session, and the session is used to manipulate the data. It implements the unit of work pattern and is capable of batching the requests to save expensive remote calls. In contrast to a document store, it is a lightweight object and can be created more frequently. For example, in web applications, a common and recommended pattern is to create a session per request, and that's exactly what we will do. So inside of here, in this function, I will create a constant session, and this will be equal to document store. Document store is imported from the lib folder. This is the document store which we initialized a second ago, and we want to open a session, so .open session. We want to call this method. The next step is to get the current tenant ID. So here's the thing, if you open the Explorer, you will find a few files: tenant cookie, tenanted entity, and also tenants.ts. Tenants.ts just hardcodes the tenants. As mentioned, we have 3 tenants: Amazon, Google, and Facebook, and they are hard-coded right here. And then I have the tenant cookie, and this is there to store the tenant ID in a cookie. So if I, for example, select Amazon, or let's say Facebook, then this new tenant ID, in this case Facebook, is now stored in my cookies. This means on the server side. And I can also quickly show it to you. If you open the inspector, go to your application, and then click on cookies, you will find this selected tenant, and in this case it's Facebook. If I switch to Amazon, it will update, and now it says Amazon. And using this function, so if I go back to my actions, get current tenant, I literally just get the current tenant from my cookie. So let's continue. We now have our session, which means we can create data. So let's create a try catch statement. And in the try statement, I want to first of all construct my object. So in this case, I want to create a blog post. I will pass all of my data, which I get from the params. This means the title, content, image URL, and I will add the tenant ID, which we get from our cookie. So in this case, Amazon. I also add the created add timestamp, and I also added right here this metadata with the collection, which is blog posts. So since RavenDB is a NoSQL database, you don't really have models. Instead, you have collections, but collections are super similar to models. If this currently confuses you, don't worry, it will make sense in a second. So since we now constructed our blog post, we can also add this data to our database. So let's say await session.store, since we want to store data, and I will pass two arguments, the blog post object and then also the ID, blog posts /. After that, the last step is to save the changes. So let's say await session.save changes. And this saves all the pending changes to the server in an atomic way, which is super cool. So in the catch statement, I will just throw a new error, and let's also finally create a finally statement. And in the finally statement, we will dispose our session. So let's say session.dispose. But now you might say, hey Jan, this all looks super cool. So we open a session, we store our new blog post somewhere, we save our changes, we dispose our session. This all looks cool, but I'm kinda confused. I don't really understand this workflow, and why do we even dispose our session? Good question. So to explain everything, the workflow and the whole concept behind the session, let's use an analogy. Let's take a notepad. So this is my notepad and it has a lot of documents. And the first step is to open a new session. This means we pretty much get a new notepad, which is completely empty. As you see here, no documents are inside of this notepad. As a second step, we store our new blog post. We pretty much take a new piece of paper, rewrite all of our content down. So in this case, this is a new blog post. So title, tenant ID, created at timestamp, collection, and so on. Our document is now finished. We take the document and we store it in our notepad. And here's the thing, when you use the store method, you don't interact with the database. The database does not know about our new documents. This right here still happens locally. Only the next step interacts with our database. Using the save changes method, we literally take our notepad with our documents, go over to the database, and then we actually just store the data in our database. This means we create these documents which are stored in this notepad. And finally, we use the dispose method. And the dispose method essentially takes all of the documents in this notepad, so 1, 2, and it just throws these documents into the trash because they are not needed anymore. We now store all of our data in our database, and therefore we don't need a local copy anymore. Now, this is a very simplified explanation, but I think things should now finally make a bit more sense. And by the way, when we call the save changes method, we store or we send all of our data in one atomic transaction. And why is it so critical to call the dispose method? Well, here's the thing. If you only have two documents, it does not really matter. If you don't dispose your session, you will just leave the documents right here on your table and forget about them, right? But let's say you again create a new blog post. This means you again take a new piece of paper and put it into your notepad. After some time, your notepad will literally have thousands of documents. And this means our application's memory is now full of old documents which are already stored in our database, but for some weird reason, we still have a copy right here, which is of course not good. And that's why we dispose our session. So with that, our server action is finished, and let's test it out. So I will go back to my application, and let's say for the title, hey, please don't forget to subscribe. For the content, I will pass some gibberish, and for the image, I will use this flower image because it looks quite nice. So I will paste the URL right here, and if I click on create post, I should get redirected, but I don't see anything. And that's because I currently don't fetch my data. But don't worry about it. Let's for now go back to the RavenDB dashboard, or in other words, to the portal. So inside of here, we still have one database. That's good, but you should see something interesting. Documents 1. I think it was successful. So let's open our database, and yes, we have a new blog post. 00001, we have the change vector, last modified, collection. This is not very important. Let's open this new record, and inside of here you should see that we have a title, content, image URL, tenant ID, created airtime stamp, and our collection. And as mentioned, since this is a NoSQL database, since Raven is a NoSQL database, we don't really have models, relations. Instead, we have collections. And on the left, you now see we have a new collection called blog post. So this is pretty much our model. So since we now see that our mutation works, again, we add our tenant ID, we can also update our page.tsx. So inside of here, I already created a simple query. So since this is a server component, I can fetch my data inside of here. So I created an async function getData. Inside of here, I first of all get my current tenant ID from my cookies. In this case, it should be Amazon, right? Let's quickly check. Yes, it should be Amazon. And as the next step, I open a new session using our document store. Again, it's super important that you import the document store from the lib folder, the document store which we initialized. And then I open, or I call the open session method to open a document session. And this will allow us to fetch, or in other words, query data. So inside of here, I have my blog posts, and this equals to await session, because this is a promise which we have to await. And here's the important thing. I use the query method, and as an argument, I pass my collection. Because again, if we go to the actions route, not to this one, but to this one, then we added our collection. And this allows us to group our data. And this also makes it easier to fetch specific data or query specific data. And here's the most important method that I use inside of here, where equals. I make sure that the tenant ID equals the tenant ID which I get from my cookies, in this case Amazon. So I will only get blog posts where the tenant ID is Amazon. So since this tenant ID is Amazon, I will get this record. If this would be, for example, let's say Google, then I would not get this data anymore, because the tenant ID does not equal Google. So let's again say current tenant ID. I also order my data using the order by descending method, and I use the created add property, and at the end I call the all method, and this materializes the query, executes requests, and returns with results. Oh, and by the way, if you want to know more about this SDK, or in other words, how to query data, then I would highly recommend this GitHub repo, so the RavenDB Node.js client. This is the official client, by the way, which we installed a second ago, and this pretty much explains everything. How to load documents, how to delete documents, how to, for example, order your data, where between. So it explains all of the methods that you have access to. So we are now finished. At the end, I return my blog posts, and finally, I also dispose the session. Again, this is super important. Please don't forget to dispose your session in your finally statement. So since we now get our data, I will update this function. So currently I hard code blog posts, and it's an empty array. Instead of doing that, blog posts will now be equal to await get data. And now let's test it out. So if I go back and do a hard refresh, I get my data. This is my blog article, my blog post. But wait, if I switch into the Google organization, I shouldn't get the data anymore, right? Let's see. Yes, correct. And that's again because our blog post is pretty much directly connected to our tenant. And since we have this where equals statement, so where equals, we make sure that the tenant ID matches the tenant ID which we provide. Since this is right now the Google tenant ID, we of course don't have a match. It does not match, and that's why we don't get any data. Nice. So now you might say, wow, Jan, this is so cool. We just implemented multi-tenancy. But is this secure? No, not really. Because here's the thing, how do we make sure that tenants only get their own data? Well, we use the where equals method, and we pass our current tenant ID. And this is fine, this works. But what is if I forget this method? What is if I comment it out? Damn, I'm in the Google organization and I see the blog post from the Amazon organization. This shouldn't happen. And the thing is, a lot of developers often forget to add this one method, because if you just code for 8 hours straight, you will forget silly things. And forgetting this one silly method means that you leak sensitive data of other tenants. And this is something that should never happen. And this is also the biggest problem of one shared database. And now you might ask me, hey Jan, what does that mean? Did we just waste 20 minutes creating all of this code for nothing? No, here's the thing. There is an easy solution which can prevent all of this. You don't have to add any where equals methods anymore. Everything will be done for you automatically. And the solution is to use a decorator. Wait, what? What even is a decorator? So here's the thing. If you go to Google and search for RavenDB multi-tenancy, then you will find this blog article. And this creator or the author of this article, Alex, went quite into detail on how to implement multi-tenancy with Raven. And the thing is, there are a lot of solutions, right? As you already know, we can use one shared database, one database per tenant. And when you use one shared database, there are again a lot of options on how you can make sure to segregate your data. One option is to use where equals, but as we already know, this is not very safe because you can often just forget it, and with that your data is now not safe anymore, or in other words, it's not segregated, isolated anymore. And the better solution is to use something which you call a decorator. So if you open your Explorer, you should find a new file called tenanted session, and inside of here I created this decorator. And what even is a decorator? Well, a decorator is pretty much just a wrapper. So I created this tenanted document session, and it's a decorator around RavenDB's document session that automatically enforces tenant isolation for all CRUD operations: create, read, update, delete. And this prevents developers from accidentally querying data without tenant filtering, storing entities without setting the tenant ID, because here's the thing, querying data is one thing, but adding, or in other words storing data, is another thing. Inside of here it's also very easy to forget the tenant ID, and with that you will now create data without having a tenant ID, which again is not good. So, and the third point is loading entities from other tenants. So security by default, no manual tenant checks needed. So let's go through this code and let's see what I created right here. So first of all, I created a class. I know, class, wow, this is like really 2010. We are in 2025. You want to probably use a function or something like that. No, in this case, a class makes the most sense and it works the best. But what do I do inside of here? Well, I create first of all this main constructor. And this main constructor takes two things: the session, and this is the underlying session that we want to wrap using our decorator. And I also get my current tenant ID from my cookies. This means Amazon, Google, or Facebook. As a next step, I have this query method, and this does the automatic filtering. This means this where equals. So inside of here, I use query.where equals and I pass my tenant ID. So what it does is that with every query, we automatically add the where equals method with the current tenant ID, which we get right here in our constructor, current tenant ID. And this prevents accidentally querying data from other tenants because we always add the where equals method, like it's always there. As a next step, I implemented this store method, and this stores an entity with automatic tenant assignment. So if the entity implements iTenanted entity, it sets the tenant ID to the current tenant. So if this currently confuses you, don't worry, pretty much we automatically set the tenant ID, which we get from our cookies, on entities before storing them in our Raven database. And then I have this load method, and this loads an entity by the ID with automatic tenant validation, and this throws an error if attempting to load another tenant's entity, as you see right here. If the entity tenant ID is not equal to the current tenant ID, I throw this error, security security violation. And then finally, I also created a delete method, and this deletes an entity with automatic tenant validation. So this throws an error if attempting to delete another tenant's entity. Note, deleting by ID is not supported. Load the entity first. This is fine. So right here, I again have my if statement. If the tenant ID or entity tenant ID is not equal to the current tenant ID, I throw an error and again say security violation. And this essentially validates the tenant's ownership before deletion. And yeah, that's already it. The last step is to export a function. So in my RavenDB file where I initialized my normal document store, I also created another function, open tenanted session. And this function expects one parameter, which is the tenant ID. And then inside of here, I say constant session is equal to document store.open session, and I return a new tenanted document session with the session, which we opened right here, and the tenant ID, which I get from my params. So as I say right here, factory function to create a tenant-aware session. This session automatically filters all queries by tenant ID, sets the tenant ID when storing entities, validates tenant ID when loading entities, and prevents cross-tenant data access. So we can now use this function. Let's go back to our page.tsx, and there is one important change that we need to make, and that's instead of now using our document store, we want to use our helper function, which we initialized inside of here, open tenanted session. So constant session will now be equal to open tenanted session that's imported from the lib folder, and as an argument I need to pass the current tenant ID. And this means inside of here I don't need to add the where equals method anymore. I will just delete it, and this will now work as expected. At least in theory. Let's test it out. So if I go back and do a hard refresh, I don't get my data. And if I go into the Amazon organization, I get my data. So this works exactly as expected. And we can now use this decorator also in our server action. So let's open the actions file. Instead of using our document store, let's delete this. And instead I will use my open tenanted session. And as an argument, I will pass the current tenant ID. And then inside of here, there's one important change needed. Instead of now passing our current tenant ID inside of here, I can just pass an empty string. This currently throws an error because in theory, the tenant ID has to be defined by either being Amazon, Facebook, or Google, but trust me, this will still work. So if I save this and go back and do a hard refresh, I won't get any errors. That's good. So let's create a new blog article. For the title, I will add some gibberish. The same thing is also true for the contents. And if I now click on create post, it should work exactly as expected. And yes, we get our blog article. And if I now go back into my Raven dashboard and go to my documents, you will see right here that we still have one collection, blog posts, but we now have two documents, document 1, document 2, and both have the same tenant ID, Amazon, Amazon. Let's do the same thing with Google. I will go into the Google organization. I will pass some gibberish for the title and content. And if I now click on create post, I will see my post right here. And if I go back into my dashboard, I will see the post or the document inside of here. This is the blog post with the tenant ID Google. Nice. It's not required anymore to add the tenant ID. Of course, I can still add it right here. So tenant ID will be equal to the current tenant ID, and then the error will go away. But in theory or practically, our decorator does all of the hard work by ensuring that the tenant ID is always added when adding data, loading data, creating data, or in other words, deleting data. And yes, with that, we are now finished with this video. You now know how to implement multi-tenancy practically. Not only have we covered the theoretical stuff, this means multi-tenancy, single-tenancy, one database per tenant, one shared database, but we also implemented multi-tenancy into our application, like for real, it really works, which is super cool. We even covered best practices by adding a decorator, something that most people don't show you right here on YouTube. A decorator is a very good practice and something that you should always implement whenever creating a multi-tenant application and using one shared database. Thank you RavenDB for making this video possible. Try out RavenDB for free by using the link in my YouTube description down below. Again, this is completely open source. If you want to, you can use the cloud offering or you can download it as I showed you in this video. Raven also, as mentioned, recently released AI-powered features, which is super cool. And in general, RavenDB is a very powerful database, and not even database, it's a powerful platform with features that are mind-blowing. And the nice thing is, RavenDB, of course, is also enterprise ready. So it's there for you if you are a startup, but also there for you if you are already a big enterprise. And now with that, I think we are finished with this video. I hope you enjoyed this video. Please don't forget to like and subscribe. It would mean a lot to me and my heart, so please do it. And now with that out of the way, see you in the next video. Bye bye.